Hi folks, and welcome to the final episode of my basic statistics course. So today I'm going to talk about a couple of things. Firstly, I will give you information about type 1 and type 2 errors in hypothesis testing. Then I will introduce statistics procedure for hypothesis testing for proportions, and I will give you some final remarks at the end of this video. It's short final episode of this course, so let's get started. First of all, I want to say that there are errors possible during your hypothesis testing. So let's have a look at the example. We have a matrix, and basically we have information about, say, some transactions. Bank use some models to predict whether the transaction is related to money laundering or it's not, and there are some real world information whether the transaction is really money laundering or it's not. And then we have four combination of these two, so true positives when reality corresponds to true prediction, and in both cases results are positive. True negatives when non-related to money laundering transaction is classified as such. And then we have two false conclusions. First false conclusion is false negative, when in reality we have money laundering happening, but bank doesn't react to that, and this is type 1 error. And another false conclusion is false positive, when we have some normal transaction being classified as a money laundering transaction, and that's type 2 error. While type 1 can cause money laundering to happen without any consequences, type 2 suggests that this might be costly in terms of time, explanations, and so for those who initiated this transaction, and also for bank, and that will be basically the loss of time and effort for people, so not very good. Here is more theoretical thing. You can see that the probability of making type 1 error is our level of significance, so it's either 10% or 5% or 1%. That's very straightforward, because we always have this tail that we can't check till the very final point, because tails of distribution always assume to go infinitely, so there is always this alpha level of significance at which we test, and then probability of type 1 error is this alpha. And probability of making type 2 error is beta, and 1 minus beta is the power of test. I want to highlight that there is always a trade-off between type 1 and type 2 errors, and next example is gonna highlight this trade-off. So say we have some person, and person in reality can be either innocent or guilty, and then this person has been put into prosecution, and judge had to decide whether the person is innocent or guilty. So we have two correct decisions when innocent person is found innocent, or when guilty person is found guilty, but we have also two combinations that are false conclusions. So person is innocent but found guilty, or defendant is guilty but found innocent. And you see that usually at certain level of evidence we can conclude that innocent person is guilty, or because sometimes we don't have enough evidence about guilty persons, we can let them go. So you see that this level that we find appropriate, of course it should be high enough to make sure that not many innocent people are arrested. Preferably none of innocent people are really in jail, but there is always a trade-off, because some guilty persons would be really smart, say, not leaving enough evidence that they are guilty for us to investigate. Okay, so now I hope that you understand the difference between type 1 and type 2 errors, and these examples were clear to you. So I want to move on and show you the last statistical technique I explained in this course, and basically that's about checking population proportions. We use z-test here, a bit modified formula. Let's move on straight forward to the example. So decision rule, very similar to what we have with this z-test. So example goes as follows. We want to know is the percentage of creamery customers who prefer chocolate ice cream over vanilla less than 80%. And we have some sample of 50 customers, and we know that 60% out of these 50 people prefer chocolate over vanilla. And let's say that we check the whole thing at 5% significance, 95% confidence. So here is our formula and basic information. So we just substitute what we observe, what we have into the formula, and we get our z-statistics. Z-statistics is -3.536, and given that population proportion is 80%, a sample of 50 people and their preferences has been translated into this z-score -3.5. Here I wanted to illustrate to you p-value approach. So basically what we are doing here is we find the corresponding p-value for this z-score, and we see that p-value equals 0.000233, and that's of course much less than 5% we originally set up. So therefore our decision would be to reject the null hypothesis. And our conclusion is, yes, there is evidence that the percentage of creamery customers who prefer chocolate ice cream over vanilla is less than 80%. Here is the source of this example, and you can check it out. So basically at this point I want to say that my course is over. There are a couple of things that we haven't covered here in a kind of straightforward manner, but the aim of the course was to give you understanding of basic ideas and basic techniques, and knowing these techniques you will be easily able to obtain more knowledge, more techniques. I really think that we've learned something, and this knowledge should be a good background for you to learn more. Finally, I want to recommend you 3 very nice books. So first book is called Naked Statistics by Charles Whelan, and I think that this book really features lots of very intuitive examples and explain statistical concepts much better than I did during this course. So please go ahead. Remember that this book is kind of for dummies, so if you're a math person or want to read something that is kind of more sophisticated, don't go for it, but otherwise it's really good book. Then I recommend you kind of intermediate book by Gujarati, Econometrics by Example. It's really very nice book because it doesn't feature any heavy formulas, heavy math, anything like that, but really easy example explaining how to use software programs and how to interpret results. And that's really easy to comprehend even if you're not very keen on math, but you need to do some econometrics. Finally, I really think that critical thinking is one of the essential competences that would be on demand on the labor market. So I highly recommend this book by Richard Nisbett called Mindware: Tools for Smart Thinking to You. It's really excellent book, and you will learn a lot about how to think critically from it. So that's all. I really want to thank you for being with me during this course. I really hope that you learned something, and I really hope that you will keep learning statistics, because it's really fun and it's really very very beneficial for you. So thank you guys, and see you maybe during some other course. Bye bye.